Here they want to know the Ksp value of bismuth sulfide, which is Bi2S3, and it has a solubility of 1.0 times 10 to the negative 15 moles per liter at 25 degrees Celsius. This is fairly small. So when we talk about solubility, it's not necessarily going to mean that when we take an ionic solid, it will dissolve all the way. There's a certain solubility at a certain temperature. So for this ionic solid, this is the solubility at 25, which is about room temperature. Um, so yeah, we're looking for that K value, which is a constant at that temperature. So this kind of tells us how much of it should be at equilibrium when it does dissolve. So this is kind of like the X value in the ice chart. So I'm not going to set up a specific ice chart here. You probably can, but I'm going to go through and just show you you don't really have to. But if you think about that solubility being the X value, solubility, um, in the ice chart, and you'll see kind of how the math would work out and then how we're going to plug in to find K. So at the beginning, it's only going to have H2O in that solid. None of them are going to affect your equilibrium. Only the aqueous ions afterwards will. So when it dissociates, these subscripts here are going to turn into your charges, and then kind of inversely your coefficients um, for each of your ions. So then here is your Ksp expression. So again, make sure you include the charges. It's important that they're brackets, they're moles per liter, and then raised to the power of their coefficients. Since no ions are, initially in solution before it gets dissolved, those concentrations are zero. Okay, so just like we do in a nice chart, we're just kind of stating that initially their concentrations are zero. The equilibrium concentrations of the ions will be determined by the amount of salt that dissolves to reach equilibrium. They tell you this number, which is that 1.0 times 10 to the negative 15. Since each of them contains two Bi plus 3 ions and three S minus 2 ions, then we can look at that change in your ice chart. And we can say that since the solubility is going to be that X value, we know that it's going to be 2 times X for Bi plus 3 and 3 times X for S minus 2. Going from there, your equilibrium concentrations are going to be that 0 plus your change, which was 2 times X, which was technically 2 times the solubility for bismuth. And then it was 0 plus 3 times X, or 3 times your solubility for sulfur. So just plugging in. So this is my equilibrium concentrations. Oops, I did that backwards. After your in your ice chart, those are your equilibrium concentrations. So we're just plugging in for K. And then our final answer would be 1.1 times 10 to the negative 73. So we know that when Ks are very small, so this is not a very soluble ionic compound.